Welcome to the video for compound interest. Our objective, we just have one. I can calculate compound interest using the compound interest formula. So first we're going to get in some vocabulary about what compound interest is. We'll see a problem, come up with, and well actually a few problems, and then we'll come up with the formula. All right, so what is compound interest? It's interest or money earned that is added to the original amount so that the added interest also earns interest from then on. And so that might make more sense once we see some numbers with that. All right, so what is the principal? The principal is just the original amount of money. So if you put $500 into your bank account and then it earns compound interest, the principal would be that $500 you originally put in. The rate is the percentage of the principal that's added each time. So you're going to make more money on your principal. You're going to make more money if you put in a larger principal because it's a percentage of that principal. So if one person puts in $100 to the same bank as another puts $1,000, the person who puts in $1,000 is going to make more money each year. Then the acronym APR stands for annual percentage rate. Banks pay a percentage each year. So the longer you keep your money in one spot, the more money you're going to make off of it. However, banks choose how often to compound differently. So you can compound, or they can compound annually, quarterly, or monthly. That it compounds annually, that means it earns interest. So the interest compounds, so earns interest on top of the interest only at the end of the year. And we'll look at what that means to compound a little more clearly in just a moment. Could also compound quarterly, so the interest would compound 4 times a year, meaning that if you started off with your $100 and there was a percentage, quarterly that interest would earn interest on top of itself, as opposed to only at the end of the year. Or you can compound monthly, where 12 times a year that interest would earn interest on top of itself. All right, so let's get into this problem here. Tony's bank gives him 3% every year on the money in his savings account. The bank pays at the end of every year. So we're going to do this annually at first. He starts off with $600 the first year. How much will he have after 10 years? So let's start off. We have our first year. Tony has $600. And we know that he's going to make 3%. So you could just say, oh, I'm going to multiply this by 3%, which would be the decimal 0.03. Whoops, sorry, not 0.003. 0.03, and you would find out the percentage that he makes is $18, and then you would have to add it on. Or another way of doing this is to say, okay, well, that's $600 times 1 plus 0.03, because 1 being, if we were to distribute this as opposed to adding this together first, 600 times 1 would be the 600, and then 600 times 0.03 would be the 18, so let me write that underneath, 600, and then plus 18, which is his interest, we would get the total amount this way. So really what we end up doing, kind of a shortcut here, is we're going to end up with 1.03. Okay, so I'm going to clean all this up, and I'm just going to go down. I'm going to erase this, but if you've already written it out, you can write below it. Really, he's doing 600 times 1 plus 0.03 would be 1.03. So times 1.03. And when he does that, he gets $618 that first year. Then his second year, it compounds. So now we're not just going 600 times 1.03 again and saying he gets $18 each year. He's going to get a little bit more each year, because we're going to take the 618 times 1.03. And when we multiply this, he gets $636.54. And if you were to break this apart, the 3% he got this year was actually $18.54. So the previous year he got $18, then he got $18.54. Then his third year, we're going to take this amount, $636.54, multiply 1.03, And on this year, he's now earned 655, or he hasn't earned it, he now has $655.64. And just for reference, on this year, since it compounded, he actually earned $19.10. So the first year he earned $18. The second year he earned $18.54. The third year he earned $19.10. Because it's compounding, he's earning a little bit more every year. Okay, well, you can see that this would be quite a long list if we want to get all the way up to 10 years here. And I have not given us that much room. So let's see if there's a pattern here. Let's see what's happening. So for the first year, we're doing 600 times 1.03 to the power of 1. And it does equal 618. For the second year, if we want to stay with that same number, 600, we're actually multiplying. All of this ends up to actually be multiplying by 1.03 squared. If you type that into your calculator, you will end up with this amount here. The third year, we have 600 times 1.03 to the power of 3. Once again, put this in your calculator if you want to check and make sure, but if you multiply these together, you are going to get this amount. So we're starting to see a pattern here. We really just have the principal times the interest added onto 1 raised to the power of the number of years. So if we just want to jump to 10 years, let's go ahead and figure that out instead of making this big long list. We would have 600 times 1.03 to the power of 10. Plug that into your calculator, and at the end of 10 years, Tony here is going to have $806.35 for doing absolutely nothing but just leaving his money into a bank account. So he earned $206.35. That may not seem like a lot of money, but keep in mind if you start off with a lot more, this is a lot more after your 10 years. But it is, either way, about $200 he earned for doing nothing. Okay, so the compound interest formula, I want to add a little bit more to it by doing some problems on the back, but we're going to come back and put it right here. And I wanted it on the front because I want you to eventually memorize it, but by knowing where all these parts and pieces come from, it's going to be easier to memorize. But before you have it memorized, I want it easily found on your piece of paper. So we'll just create this box here. We're going to do a few problems on the back and then see what the actual formula is. Okay, so now we start off with $6,000 and it's compounded quarterly at 3% interest for 5 years. Well, what we've been working with so far is that we're going to take 6,000 and we're going to multiply it, and I'm going to break it apart into the two pieces, 1 plus 0.03 to the power of 5. But what's changing now is this quarterly is going to make all the difference in our formula. The bank is still paying 3% APR, and actually these should probably all say APR on them, but the bank still pays the same percentage over the entire year. But now it's going to be broken up quarterly, and each quarter, whatever's already been earned at that point is going to be added on to the principal, and then interest is going to be made on top of that new amount. So we're going to change our formula a little bit. This 0.03 still has to last over 4 years, so we're going to divide it by 4 here. I'm just going to stretch my parentheses down here to fit it all in. And now this up top here is going to change also, because it's not just happening 5 times, it's happening 5 times the 4 times a year it happens. So 4 times a year for 5 years. Okay, so our two new parts here is this and this. And then it's just a matter of following order of operations correctly. So we're going to start inside the parentheses, once again, PEMDAS. First thing, start inside the parentheses, see what you can simplify. Well, inside these parentheses, I then again start at the beginning of PEMDAS. There aren't any more parentheses inside the parentheses. There aren't any exponents inside the parentheses, but I need to multiply and divide before I add and subtract. Okay, so be very careful of that. Make sure that you divide this before you add them together. So we'll go 0.03 divided by 4 is us 0.007, and then when I add it to 1, this is going to become, I'll do my 6,000 over here, times 1.007. Okay, make sure you multiply these exponents together. 5 times 4 is 20. And now you can just plug all this into your calculator. And for this problem here, we end up with $6,967.10. And you can see that this person who invested $6,000 for 5 years made $967.10. So a much bigger profit there. All right, before we go to do the rest of these, let's go ahead and jump back and actually write in our formula now. Okay, our formula is A equals P times 1 plus R, that is an R, over N, all to the power of R times T. All right, so what are each of these pieces here? A is the ending amount. P is the principal, so what we're starting with. R is the rate. N, how many times a year it's compounded, and T, the number of years. All right, so now we have our formula. Let's jump back to the back and try a couple more problems, then I'll leave one for you to do on your own. Okay, so I'm going to go ahead and rewrite our formula here just so we have it right in front of us. But A equals P times 1 plus R over N, all times, I should have longer parentheses here, all times N times T. And you know what, going back here, I realized that I didn't put N times T, I put R times T. Too bad these numbers look too much alike. Because keep in mind, we want to divide by how many times it's compacted to make that rate stretch over the whole year, and then multiply by the number of times is not just going to be the years, it's going to be the times per year times the number of years. Okay, so make sure you fix that on the front. Make sure you have the correct formula. Sorry about that. All right. And then coming down here, it's just a matter of plug and chug. We have A amount equals 850, which is our principal, times, wrote in the skeleton here of the rest, times 1 plus our rate, which we're going to turn into a decimal, so we have to move the decimal point twice to the left, 1, 2, over the number of times it's compounded per year. So it says monthly right there, that means 12 times per year, times, once again, the number of times per year, 12, and then lastly, we're going to put in the number of years, so times 8. Very pretty, lots of colors here. All right, let's figure this out. So to simplify, order of operations, do the 0.12 divided by 12 and then add on the 1. So we get 850 times 1.01, and then 12 times 8 is 96. Go ahead and plug all this into your calculator, and we get $2,209.38. Okay, once again, I'm going to keep that formula in view so that we can see it. But we have $5,000, so let's just go ahead and start to write this out. $5,000 times, I'm just getting this from the formula, 1 plus, I'm going to put my rate on top, so 8%, move the decimal point 2 places to the left, 0.8. Then number of times per year is my N. Number of times per year, quarterly, would be 4. And then we're going to raise the whole thing to the power of the number of times per year times the number of years. So quarterly, once again, would be 4 times the number of years, 5 years, and then go ahead and figure this all out. So we do 5,000 times 1 plus 0.08 divided by 4, and we get 1.02. Raise the whole thing to 4 times 5 is 20. And the whole thing ends up to be $7,429.74. Make sure you round correctly. One left for you to try. Please give it a try so we can go over it in class and you had a chance to see if you know how to do this correct. And then please write down any questions that you have for me. All right, see you soon.